Hi, this is Lisa Knight, and I'm going to talk about the problems that you guys mentioned in your discussion forum this week. Um, so, we're concentrating on self check 4 problems, and the very first problem that was mentioned was the mass versus weight problem. So, let's review mass and weight. Mass is how much stuff you're made out of, and it's measured in kilograms. And mass never changes because it literally is how many atoms you're made out of. Weight, on the other hand, is the force due to gravity acting on you. And it changes with gravity. So if gravity of the object that you're standing on or that you're near is different, then your weight will be different. So if you go to the moon, you'll always have the same mass that you had on Earth, but you won't have the same weight. Weight, symbolized by Fg, is equal to mass times gravity, where on Earth gravity is 9.8 meters per second squared. So if you have a 20 kilogram mass person on Earth and Mars has only 0.38 times the gravity, how does that affect your weight? Well, you on both places you have the same mass. So on Earth, your mass is 20 kilograms times gravity of Earth, 9.8, which is going to give you a mass of 1960 newtons. On Mars, however, gravity is only 3.7. So now your weight on Mars would be 20 times 3.7. How did I find a 3.7? I multiplied 0.38 times 9.8. Simple. So whatever 20 is times 3.7, which is going to be around 1500 newtons versus the 1960 newtons for Earth. So you weigh less on Mars than you do on Earth simply because there's less gravity. So problem 9, 10, and 20 all require you to draw vector diagrams to be able to visualize this. So the key to using Newton's second law to solve problems is to realize that Newton's second law, F equals ma, that the F is a net force, a total force acting on the object. The physics classroom does a really good job teaching you what is meant by net force in a very simple way. And I would recommend you do some of the concept builders for net force from physics classroom because those are really, really good to get the concept across. They're not real hard, but they get the concept across for sure. So you're pushing this lawnmower, and the lawnmower, let me find it here so I can read it out to you. You've got this figure, and it tells you that the net force in the picture, in my example, is 55 newtons, and it tells you that there's friction acting on the object. So by just kind of simplifying this diagram, and this is not the complete diagram, I would also put in the weight and the normal force showing that they balance out. But just looking at what's going on in the x direction, you're pushing it forward with some applied force, and there's friction force acting on it. And the net force is in the forward direction. And the net force is given to you, and the friction force is given to you. So the first thing you have to do in these problems is number 1, draw a vector diagram, a free body diagram. If you can't conceptualize what forces are acting on the object, you're not going to be able to find the net force. So the net force is equal to the sum of all the forces acting on the object. And this net force is in the x direction here. So you can only add vectors that are in the x direction. The ones that are pointing to the east are positive forces, and the ones that are pointing to the west are negative forces. Friction opposes you, it slows you down. So the net force in this case is equal to your force that you're pushing with minus the friction force. They told you that the net force was 55 newtons, and they told you that the friction force was 26 newtons. So now you can just plug and chug and find the force that you're pushing with on the lawnmower. In part B, as I've mentioned before, physics builds on itself. So the kinematics equations never go away. In part B, it says that it's moving at 1.5 meters per second and that it comes to a stop. And it wants to know how far it's going to move before it comes to a stop. So it says when your force of F is removed. So what is the net force? If I remove this force and I just give it a push and let go of it, eventually it's going to come to a stop. So that force, the only force that's acting on it is the friction force. So the net force would be 26 newtons, and that's going to cause it to slow down. So in order to solve this, I know that VI is 1.5. I know that VF is 0. And to find A, I'm going to use Newton's second law. Net force causes it to accelerate, right? Slow down in this case. The net force is negative 6 newtons, and A is whatever that comes out to be. It's going to be a negative number. So you'll come out and you'll find A using friction as your net force. And then you'll want to find X. So you will have to go through your kinematics equations and find the equation that relates to a VI, a VF, A, and a distance. And I accidentally pulled up the free fall equations. The only difference is that instead of G, it's A, and instead of X, it's Y. So these are still, the same equations. They just have a little bit different notation. But if you look at this, the only equation in here that you can really use is this equation. See, I don't have any time listed here. So I need to find, this one has time, this one has time, this one has time. I can't use them. So I'm going to use this equation here. And this y minus y naught, or delta x, is what I'm looking for. I'm looking for xf minus xi. That's what I'm looking for, the change in displacement. And I know what my final speed is. I know what my initial speed is. I know what 2 is. And I know what A is because I'm going to have to calculate A. So this is really a multi-step problem. In problem 10, you have a rocket sled. So this is a rocket sled. And it's going to be decelerated at, for my problem, it's 191 meters per second squared. And you know its mass. So it's got some friction force that's causing it to come to a stop. First thing I'm going to do is draw my vector diagram. It has weight. The ground is pushing back equal and opposite to it. So it's in equilibrium in the y direction. So these forces cancel out and I'm not worried about them. The only force that's acting on it when it comes to a stop is friction again. And I want to find that friction force. Well, I know that that friction force is causing it to slow down at 191 meters per second squared. So I know what my mass is. It was given to me. I know that what my deceleration is. I have to remember to put a negative in there because it's decelerating. And I'm going to use F net equals MA. And I'm going to find F net, which is my friction force. It will be a negative number too because it's friction. It always acts up against you. And then in problem 20, I'm only going to set up part A because this will allow you to understand kind of what's going on here. All right, so in problem 10, let me read that to you because you do have to read it and you have to draw a picture of it to kind of understand what's going on. So in the first part of problem, I said 10, I meant 20. You have a commercial airplane which is being pushed out of a loading tractor. Okay, so you've got an 1,800 kilogram tractor and it's exerting a 18,000 Newton force backward. Okay, so I've got that drawn in. And the system experiences resistive forces of 2,400 newtons. So if it's resisting that, then it would be 2,400 newtons in the other way. If the acceleration is 0.130 meters per second squared, what is the mass of the airplane in kilograms? So I'm going to use F equals ma. Now I drew my diagram here. I've got my weight vector and my normal force vector. I would label those if I was going to turn these in. They're equal and opposite to each other, so they're bouncing. I don't have to worry about this thing moving up or down. I've got 1,800 minus 2,400 newtons. I'm going to say that in this diagram, the left is positive and the right is negative, just to make it so I don't have weird numbers. And I've got 18,000 minus 24,000 equals, that's my net force, equals my mass times my acceleration, which is 0.130. And now I just solve for mass. In B, you're going to do something similar, but you're now thinking about what's going on with the airplane. So you need to pay attention to drawing the correct diagram for the airplane. Hopefully that'll help you understand some of the Googled answers you guys are getting. So in these problems, you need to, number 1, draw a vector diagram. Number 2, start with F net equals ma. Figure out what the net force is on this side, and then substitute in for M and A. And one of these things will be missing. Hope it helps.